and welcome to the lecture on pair plots. In this lecture, we'll see how we can draw graphs by using pair plots. As usual, we start by importing the libraries and modules that we need. I copied this from our previous lecture. We'll be using Seaborn's iris dataset and the tips dataset for plotting. Pair plots allow us to see the relationship between two variables. Let's see an example by first looking at the iris dataset. Let's import the iris dataset by using the load dataset method. So sns.load dataset, then we'll pass iris, and let's save this in a variable called iris. Once we have that, we'll call the pair plot method that Seaborn has. So sns.pairplot, and then we simply pass our dataset, which is iris, and run it. So this is a nice pair plot representation of our iris dataset. I will zoom out so that you can see the entire graph. So here on the x-axis we have sepal length, sepal width, petal length, and petal width, and we have the same variables on the y-axis: petal length, petal width, sepal length, and sepal width. Here in the diagonal we have histograms, and the rest of the graphs are scatter plots. So the diagonals represent the relationship between those two variables themselves. For instance, here you will see the relationship of petal width to itself. So petal width to petal width. So the relationship between the variable to itself is represented by this diagonal, which is a histogram, right? So 1, 2, 3, 4. So if we take this histogram, that's the relationship between sepal width to itself, which is sepal width. And the rest of the scatter plots show the relationship between one variable to another. For instance, if we take this scatter plot, it shows us the relationship between sepal length, and if you go down, we see here petal length. So it gives us a visual of the relationship between sepal length and petal length. Similarly, if we take this scatter plot, it shows us the relationship between petal width and petal length, right? It shows more of a positive relationship. And by default, we have a blue color for our pair plot. Now let me zoom in. Next, let's see a pair plot of our tips dataset. First, let's import our tips dataset and save it in a variable called tips. So sns.load underscore dataset, and then we pass name of our dataset, which is tips. Once we load our tips dataset, let's call the pair plot method that Seaborn has. So sns.pairplot, and we simply pass our tips dataset and run it. Now we have a pair plot of our tips dataset. See, again, the diagonal represents the relationship of the variable to itself, whereas the scatter plots represent the relationship of the variable to another variable. For instance, here it shows us the relationship between tip and size, whereas this scatter plot shows us the relationship between total bill and tip. So far in the above two examples, we only passed our dataset, right? This pair plot method also accepts other attributes. One such attribute is called hue. So let's see how we can pass the hue attribute. Okay, so SNS dot pair plot, then we'll use our iris dataset, and for hue we'll pass species and run it. So we have a pair plot of our iris dataset, and we have a species hue, and we see the three iris species: Setosa, Virginica, and Versicolor, and the different colors. You see how nice it looks. So from here we can tell, for instance, the red one is Virginica, and if we simply take the scatter plot here, we see that Iris Virginica has the highest petal width as well as petal length, right? And Iris Setosa has the smallest petal width as well as the smallest petal length. We can tell that from the scatter plot. And as a general, we can see the relationship between petal width and petal length for the three species as one. There is more of a direct relationship between petal length and petal width. That means the higher the petal width, the higher the petal length. And we can see some relationship between the other variables by considering the various scatter plots. And again, the diagonals are histograms, and they show the relationship of one variable to itself. Next, we'll see another attribute known as palette. So using this attribute, we can have various kinds of color for our pair plot. Let's see an example. So SNS.pair plot, we pass our iris dataset, and then let's use hue as species, which we just saw, and this time we'll pass another attribute known as palette, and we have different values for palettes. Let's see one value known as HUSL and run it. So this is the palette. You see how it looks. So this is one example of, or one value of a palette, HUSL. There are also other attributes. There are also other values for our palette attributes. One such palette is RDBU. Let me show you an example of that. So for palette, let's pass RDBU and run it. So that's the RDBU palette. And another one, if I remember correctly, it's called blues. Let me pass that. blues_D and run it. So here we have different shades of blue from light to dark blue. Depending on your preference, you can use different kinds of palettes. Great. Next, let's look at another attribute that we can pass for our pair plot. It's called the markers attribute. Using this attribute, we can use different markers for our three different species. Let's look at an example. So you have SNS.pair plot, and we'll be using the iris dataset. For hue, let's pass species, and let's use our markers attribute, and then we can pass a list of values for our marker. For instance, we can pass a circle or O. We can pass, let's say, D for diamonds, and then S for squares. Okay, let's also pass a palette attribute, and let's set our palette to be a QSL. Okay, and our markers, we have a circle, diamond, and square. Let's see what it looks like. So here for species, we see a circle for setosa. Let me zoom in. So here you see a circle representation for setosa, a diamond for versicolor, and a square for virginica. So that's the marker attribute. Since we have 3 Irish species, we passed 3 different markers, right? Similarly, we can pass different kinds of markers. Let's see one more example. Let me paste it and pass, let's say, the plus sign as one of the markers, and let's run it. So here we have a plus sign for versicolor. So that's the markers attribute. Let me zoom out now. In all the examples we saw, we were able to visualize all of the variables. For instance, for our iris dataset, we are able to visualize sepal length, sepal width, petal length, and petal width. What if we want to visualize only 2 variables? Let's say we want to see the relationship between sepal length and sepal width. We can also do that by using pair plots, and for that we'll be passing another attribute or parameter known as vars for variable. So by passing the vars attribute, we can specify which variables we want to see. Let's look at an example. So SNS.pair plot, and we pass our iris dataset, and let's use the vars attribute, and for its value we pass a list of the variables that we want to see. For instance, let's see the relationship between sepal length and sepal width. So sepal length and then sepal width. Okay, if we run this, we see a nice pair plot to show us the relationship between sepal length and sepal width. Again, the diagonal is a histogram, and it shows the relationship of a given variable to itself. Okay, so if we take the scatter plot, it shows us the relationship between sepal length and sepal width, and same thing here between sepal width and sepal length. That's how we can see a subplot of the specific variables we want to see. And that's possible by using the vars attribute. Let's see one more example of the vars attribute by using our tips dataset. So SNS.pair plot, we pass our tips dataset, and for the vars attribute, we'll pass the variables that we want to see. Let's say we want to see the relationship between total bill and tip. So we pass those as a list and run it. So here's the relationship between total bill and tips. Hello everyone, and welcome back. In this lecture, we'll continue our discussion of pair plots. In the previous lecture, we saw how we could use pair plots to see the relationship between our variables, and we looked at the iris dataset to see the